This is Mastering Mathematics with your teacher, Karen Weston.
Hello Antigua Barbuda and the rest of the world. Welcome again to another in the series Mastering Mathematics, a program sponsored by the Ministry of Education using its EBU unit and our Center for Mathematics Education in Research, and Warrior Education 2 will come on later, and of course ABS Television. Today we continue the fight because we are going to make certain we will never be the laughing stock of this world again and saying Antiguans and Barbudans can't do mathematics. We are going to say we can do mathematics. And especially as we remember Sean through this boat, a voyage that he will now take that will leave his human remains out of our sight, but his spirit will always be with us. We ask you once again to pray for the family as we continue to champion the cause of education in this great nation. And again, we pray for our beloved country of Antigua and Barbuda. Yes, we have work to do. Today, we are going to continue the fight where we're going to bring to you some more operations in terms of our fractions, which is proper fractions, and today we will be doing the operation for subtraction. I want to give you two words. Remember when we said that we were looking at equivalent fraction, we said we could reduce them, okay? In that aspect, that term reduce was used to say we could express the same quantity in another version, but the value would be the same. Today, we're getting into subtraction. And what it means is that we're going to be taking off some from the original quantity or total we would have started with. All right? And these terms and explanation will be important for our students when we get to our problem solving operations, so that people will not be able to say, oh, I didn't know if I had to divide or if I had to subtract. So take your time, make certain the terminologies are important. Reduction, because a child could easily say reduction means we are making smaller. Somebody else could use that same term in terms of subtraction to say we are making the amount smaller. But in terms of division, in making it smaller, it's in terms of expressing it in a different form, but the value remains the same. We don't have to spend too much time now because we're going to be getting into the operation of subtraction of proper fractions, okay? So it is the subtraction of proper fractions. And symbolically for us in mathematics, that subtraction sign is represented by a dash. All right, so we know the symbol for subtraction, what it is. Last week we were adding, and adding means we are increasing the quantity. Subtraction means today we are going to be taking off some from the sum that we started with. What we are going to see is that now that we have laid foundation, everybody knows how to find LCM. Everybody knows what we mean when we use the term prime numbers. We can go ahead much quicker and at a faster pace, not to run away from the students who would be calling slow learners. All right, but teachers, what I want to emphasize is the fact that having laid a good foundation, we are now ready to thrust on and to go faster. Okay, so we have to subtract the a half, and it is minus a third. Okay, so the name of this fraction, it's a half, and this is minus, name of this fraction is a third. They're going to learn them that because every time we talk about them, we use the words, the mathematical terms for them. Okay. The procedure, I am saying it's the same as what we were doing for the addition, but the only difference now, we're going to be subtracting. So our first step, we would say, is to find the LCM. So, and the numbers are 2 and 3. Do we know something about these numbers? What type of numbers are they? Do we want to guess? Or do we want to say, because we know now what type of numbers they are? What would we be using as our litmus test to say what type of numbers they are? Cameraman, can you tell me what type of numbers we're dealing with today to find our LCM? Oh, he too has gone silent on me. So they are prime numbers, all right? Why did he say they were prime numbers? Grannies, I hear you shouting behind and saying, Miss Weston, you can't kill me this time. And you're right, because they have only 2 factors. Right, so our prime numbers, all right, any number that has only 2 factors, 1 and itself is a prime number. 1 cannot be a prime number because it has only 1 factor. So LCM, 22 goes once, and 2, we are bringing down the 3 because we won't get 2 going into it without a remainder. And then we have 1 and we have 1. And once we reach this line with all 1s, we know that that's the end of the process of finding the LCM. So it's now equal to 2 times 3, and that is equal to 6. And we now be calling those the prime factors of 6. All right, so we have 6. And we go 2 into 6 goes 3 times. 3 times 1, so what number we get when we divide, we multiply it by the numerator. And so we're going to say 2 into 6 goes 3 times. 3 times 1 would give us 3. And it's minus 3 into 6 goes 2 times. 2 times 1 would give you 2. And we're subtracting, all right? And my little people will be saying they're taking away. When we take away, then it would be the first number, 3 minus 2, okay? And even if we didn't know, give them their little strokes, minus 2. So we have 2 cancelling with 2, and we are left with 1. So that our answer here would now be equal to 1 upon 6, which is called 1/6. And that's the answer. All right? So you see right away the subtraction. The only thing that's different in terms of the process and the procedure is the symbolic mathematical signs. This time we're not adding 2, we are taking off. And so we're getting it's equal to 1/6. Yes, we're dealing with our subtraction. So you see, we don't have to stay long on them now, because all we're doing is just changing from addition to subtraction using the same process that we did last time. And so you're happy with that. I'm going to send you on a little break. Then we're going to come back, work one more of these, and guess what? We're going straight into the mixed fraction part of it. Yes, we are running because the foundation has been set. So once we do that, and teachers, you can almost sit and wait on your little students now to come for marking. You're putting one example on the board, then you're putting another one, and they're coming up and showing you. Send your teachers, your makeshift teachers in the classroom. Let the peer group begin. All right? So take your break, and we'll be right back.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
Don't look on what I cannot do. Focus on what I can do. I may not say what I do, but I can hear and feel it I strongly.
I may not hear, but that does not and should not affect my ability to learn and to function in the real world.
I am a gifted student. I need the opportunity to soar. Support me in my climb to higher levels of learning.
Some of our children have special educational needs. They have a right to an education. So let us teach them the way that they learn and help them to achieve their full potential. Okay. Yes, so you had your break, and you know what? It's just working time now. Let us look, because this time I just realized that in doing the addition, I did not show you or take a specific example into consideration. So we're going to do it now for the subtraction first of all, and then I'm going to change the sign from a subtraction sign to an addition sign and ask you what I should be doing. All right? But let's take this one. So we have subtraction. And look at what we have. It is 7 over 8, 7/8, minus 3 over 8, 3/8. All right? What are we seeing? Keep your eyes on the denominators. What do we have? The denominators are the same. So what do we do? Do we have to go and find an LCM? No. What did we say the LCM represents? We want to bring the denominator to a common value. So where the denominators are the same, we don't have to find the LCM. Because those two houses, if we call these houses, okay, they would have been built on the same foundation. So they're already holding hands. But up here, we're going to say we want to take off this amount from here. Okay? So all we have to do is to put down our 8 because the foundation is already the same. And you're saying, I don't like this humongous house. We have to take off a part of it, a fraction of it. So we have 7/8, and it is minus 3/8. So foundations are the same. So we write it right away as our LCM. That is what we have to do. Okay, so let's go slowly with this. When the denominators are the same, we don't want to find any LCM. It is already the LCM because it is the foundation for the same house. All right? And what we do, we may be adding, subtracting, multiplying, or dividing, but the foundation here is already set. So we put it down, and then this time you're saying we want to take off 3/8 from the 7/8. All right? So that is what it is. So we don't now be saying 8 into 8 goes once, 1 times 7 will be 7, and it's minus 8 into 8 goes once, and 3 times 1 would be 3. So we see then that it is 7 minus 8. Keep your eyes on these two numbers, okay? Because can you see that they're the same numbers that we have up here, that we were saying that we are subtracting? Can you see that it was 7 minus 7/8 minus 3/8? And when we did, following our procedure for the fractions, you still see we are getting 7 minus 8. And then our answer would be 7 minus 3 would leave us with 4/8. Okay, that would be the answer. But if we're smart and somebody asks, can we reduce that further? That is having the same quantity but make it smaller. And you're saying, yes, Miss Weston, because I learned my tables and I know there are 2 even numbers here. So I can divide the numerator by 2 and the denominator by 2. And I would be getting then for my answer, 2 into 4 would give me 2, and it's over 2 into it goes 4. And what can we still do? Okay. And again, you can say we can divide by 2, divide by 2, and we will be getting that it is 1/2. Or if we were up here and we knew our tables, 4/8, and you're smart enough when you say 4, you say 4 ones are 4, 4 twos are 8, and we're right there. So we could have gone right away and say divided by 4, divided by 4, and it is the same thing as 1/2. And that is what we would have been getting for our answer. And of course, we teach children to say, examine the numbers and see what is the relationship between 4 and 8. And they would tell you right away, it's a half, all right? If you have 8 mangoes and you're giving away 4, you have given away half of the amount that you had. So that is what we are doing. Now, having examined our operation and getting our answers, I want to go back up here because there's a rule that's coming out from this. If we are observing, we had 7/8 and it's minus 3/8. And when we did our operation, get our LCM, did our 8 into 8 goes once, 7 times that, we still see that we are ending up with 7 minus 3/8. Okay, so what do we say? If I gave you 2 over, let's call this, not 2, let's call this now 8/9, and it is minus 2/9, what do we think we're going to get? Let us do it again and see. We just said the denominators are the same, so we just have to write it down. The LCM would be 9, and we'd be going 9 into 9 goes once. 1 times 8 would give you 8, and it's minus 9 into 9 goes once. 1 times 2 would give you 2. Okay, keep your eyes up here. All right, what do we see we have? Okay, so that's minus, okay? And we can see right away. Let us look and examine the numbers. 9, LCM 9. 8 first number, 8 first number, minus 2, 2. Okay? So can we, so 8 minus 2 would give me 6/9. And yes, we can reduce it because we know right away that our 3 times table would take us there. So it's divided by 3, divided by 3, okay, by 3. And we're going to end up with 3 into 6 goes 2, and into this will go 3 times. So we like to leave our fractions in their smallest terms. But if a child came up with 6/9, it is still correct. Okay. Now, I'm still giving you time to see if you can observe the relationship between what I want you to tell me. Help me to construct this rule. Okay? We are subtracting and the denominators are the same. We are asking you to examine what we're getting for answers up here and what we have as our numerators. All right? We're going to give you another example and to see if we're catching on to what rule we should be using when we are subtracting and the denominators are the same. Let's give you another one. Suppose we had to do, and it is 6 over, and this time it can be 7, and it's minus 3 over 7. Again, we are following our rules, and we say denominators are the same, so we don't have to go into anything. We go here, and it is 7, because again, why are we writing back our 7? The foundations are the same. All right, but we're just taking off a piece from that house. So then we're saying 7 into 7 goes once. 1 times 6 will give us our 6. And it is minus. 7 into 7 goes once. 1 times 3 would give you your 3. And then so again we do our subtraction. And it would be 6, would give me a 3. Write it properly. So it would be 3 over 7. And that's the answer. Again, we ask you to observe numerator starting with a 6, taking off a negative 3. What do we notice down here? Hear the song coming out, teachers? All right, let them sing in the classroom too. Okay? So, by now, shall we tell them, those who didn't get it? Do you want your teachers to go and help them to see what is happening? Let the children talk about it. Let them see, because grannies, I'm sure you're looking. Let us look again. Let us just take you through. 7 eighths minus 3 eighths. What's the numerator? 7. And it's minus, what as numerator? 3. When we came down and we did our operation, what do we have up here? 7 minus 3. Okay? We gave you another one. And it was 8 over 9, and it's minus 2 over 9. What do we have here? 8 minus 2 for numerator. What did we get down here? And it is 8 minus 2. Came over here, and we gave you this one. Okay? Now, what did we give you? This, okay, 7. 6 over 7, and it's minus 3 over 7. So what did we get? Here we have 6 numerator minus numerator 3. And here when we did it, 6 minus 3 over 7. Can we say a rule now? Yes, you're so smart. You're right. That is what we're saying. If the denominators are the same, all we have to do is just to subtract the numerators. Denominators are the same. We just have to subtract the numerators. So let us just give you 1 to end off with. And if we had 3 over 10, and it's minus 1 upon 10, denominators are the same. So we're saying write back the denominator 10, and it's just 3 minus 1. The answer is just 2 upon 10. That is what we do. When the denominators are the same, we just subtract the numerator. If the sign was addition, so we had 3 over 10, and it's plus 1 over 10, we would just add the numerators. So it would be, LCM would be 10, and 3 plus 1 would give you 4. All right? So denominators are the same, and that is what we are doing. So we have no big problems. When the denominators are different, we would go and find an LCM. If the denominators are the same, we write back the number ones and then just add or subtract our numerators. So that is the operation that we're doing for proper fractions in terms of subtraction. In our next class, we'll be looking at what do we do when we're subtracting mixed fractions. That is going to be our next operation. So for tonight, you are being sent home to construct some for yourself, make up your own fractions, do your subtraction, see to it that you're getting them out. Do some with the denominators, because those with the denominators are the same, would be like when you're just playing round and round in worry, all right? So after a time, you are going to have fun with it. Now, we want to thank you very much for viewing ABS Television and for making certain that you want to be a part of the population that says mathematics is. Because increasingly, as we're going to find out with sugar no longer our industry, we have to increase in terms of what the structure, the complexity of the economy is, and therefore mathematics is going to be important for everything that is done. And so students, we want you to have a sound base. And yes, skills are important, and the schools are not behind. No, that is why they've sent people like me for training, so that we can know we must link what is taught in school with what the real world is. So when you hear your students saying they have to do an SPA for mathematics, it is because we wanted them to say, use the theoretical things that you're doing in the classroom and apply it to something in your environment. Where in the environment would you be using this? And of course, I heard a discussion and asking, are we allowing our students in the secondary schools to have a worldview and to have a real world situation in terms of, yes, we are. No longer are they just learning something and then the information stays in the classroom and then it's just for a test. No, we are hitting them immediately. Where would you be using this in the real world? And especially in the business classes, these people are posted to business places and are given an opportunity. So you hear, last time I had a workshop as a boot camp for my mathematics students. The students from Otters Comprehensive could not join us because they were out on their work job practicing. So that is being done. Okay, it's a part of our education system. We talk about students must have techno-mathematical literacies. And you are right. We're going to have to retrain those students who left school without a skill and without that sound base. Because still we can tell you there's no transfer in terms of mathematical operation and the pedagogy that is worked in the classroom. But the foundational knowledge is required, because the activity that they're going to be asked to perform and the technological tools they're going to be asked to use will be mathematically based. That is my research. All right? And so we are training our students for that sort of thing. Our educational system is a progressive one, and we are getting our students prepared for the 21st century. It doesn't matter who says what. The education system is progressing, and we must make certain that our students are up, because we want them to be citizens of the world. So until tomorrow, when we come back to you again to teach you some more, to make certain that you're ready for the economies of the 21st century and beyond, this is Karen Weston saying, do enjoy the rest of your evening.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.